Hello, class. This is Mr. Hart, and in this podcast, I want to start on the reactions chapter, okay, going over chemical reactions. And so the first thing we need to ask is, what is a chemical reaction? Okay, you probably have heard of chemical reactions before, and you probably recognize explosions as a chemical reaction. That's a very common one, but just because it's a chemical reaction doesn't mean it's an explosion. Okay, there's other ways these things can react and other things we can see. Okay, but we want to make sure we understand what a chemical reaction actually is. Okay, and a chemical reaction is just a process in which a set of substances changes chemically into a different substance. Okay, you can think of, for example, taking hydrogen gas and oxygen gas and combining them together to make water. Okay, we can see this here in this picture. So if we take some hydrogen gas, okay, shown with these guys, and some oxygen gas, and then we combine them together, we can actually make water. Okay, and water is a liquid, whereas these two guys are gases. Okay, so they're definitely not the same thing. Hydrogen is not the same as water, and oxygen is not the same as water. And so these are chemically different substances than what we started with, right? And so we're breaking these chemical bonds, like we talked about in the last chapter. Chemical bonds, we're breaking them, and we're rearranging these bonds and these atoms to make new substances. Okay, this is what a chemical reaction does. Okay, and so we watched this quick little video about a chemical reaction where Bill Nye takes some iron, okay, and he combines it with some oxygen, okay, and when he does that, he ends up with iron oxide, okay, and iron oxide is actually rust. And so, if you watch the video, you'll see this kind of orangish color stuff that ends up at the bottom. That's actually rust he's making. So he's taking iron and oxygen, two completely different substances, and he's making an entirely new substance, iron oxide or rust. Okay? And so that's a great example of a chemical reaction. Okay? And so we're talking about a lot about taking new substances and making a different substance, and we want to be a little bit more particular in our terminology. Okay, or in other words, we want to make sure we know what we're talking about. And so we make up these two terms. Okay, there's the reactant and the product in every chemical reaction, or there's multiple reactants and multiple products in every chemical reaction. Okay, so the reactants is the substance that starts a chemical reaction. Okay, or the stuff we start with, you can think of. And the product is the substance produced after the reaction. So if we go back to the Bill Nye example, we have iron and oxygen gas, O2, and that yields iron oxide. Okay. Well, in this case, these guys over here are going to be the reactants. Okay. And this guy over here is going to be the product. Okay. And so you could say that iron and oxygen are the reactants and iron oxide is the product. Okay? And so again, nothing too dramatic. It's pretty simple, right? Just these guys on this side make this guy on the right side. These guys are reactants, these guys are the products. Okay? But it really helps when we're trying to describe the chemical reaction and we can know exactly what we're talking about. Okay? Here's another example. We take some CH4, which is methane gas, we combine it with some O2, which is oxygen, and you end up with carbon dioxide and H2O, which is water. Okay? So in this case, these two guys, the methane and the oxygen, are the reactants, and these two guys, the carbon dioxide and the water, are the products. Okay, so these are the reactants on the left side, these guys are the products. Okay? Here's another word for you to know. This little arrow you see, okay, shows what's happening, right? These guys are going to turn into these guys. But there's a special name for that arrow, or when we're kind of saying it in layman's terms, we say yields. Okay, so these guys yield or yields these guys. Okay, so yield or yields. Okay, and so it makes it easier to say in English, right, rather than having to describe the formulas. So then I can say you take methane and oxygen gas, and that yields carbon dioxide and water. Okay, that's a lot easier to say than trying to write out the whole formula. Okay? So if you are making up participation, try to do this question right here. Take a look at these four formulas and try to identify the reactants and the products in each one. Okay, so let's go ahead and do that. All right, let's move on. So here's a little bit more terminology we want to identify. Okay, so there's the idea of an irreversible reaction, which is pretty much what it sounds like, a reaction that cannot be reversed, okay, once it's taken place. So imagine, like cooking eggs or baking a pie or whatever it is, right? Once you cook it or bake it or do whatever you want to it, it's pretty much the way it's going to be, right? Once you bake a cake, you can't take the stuff back out of it and get the eggs and the milk and the sugar and all that stuff back out, right? It's already been mixed and chemically reacted at that point. And so that's an irreversible reaction. Okay, something once it's taken place, you can't do anything about it. Okay, here's some other examples. Okay, like burning wood. Okay, once you burn wood, you get ash and smoke, right? You can't take the ash and smoke and put it back together and get wood out. Okay, cooking food, you can't get the ingredients out once you make them. Rotting a banana, you can't, suck the oxygen and other stuff out and get a normal banana. Same with milk going sour. Okay, cellular respiration, breathing. When you breathe in oxygen and then breathe out CO2, you can't reverse that process. You can't take in CO2 and breathe out oxygen. Okay, so that's an irreversible reaction. Digesting food. Once you digest food, okay, you can't get the food back out. Okay, it's different once it comes back out. Okay, and so the reverse of that is, or I should say the opposite of that, to avoid confusion. The opposite of that is a reversible reaction. So this is a reaction that works in either direction. So we looked at this reaction before of hydrogen gas and oxygen gas turning into water. Well, we can actually go the reverse direction. So if I take water and I break those chemical bonds, I can actually get back out hydrogen and oxygen gas. Okay? So in most cases, things are irreversible reactions. Most of the ones we're familiar with are going to be irreversible reactions, but we can get a lot of reversible reactions. It just depends on what it is. But just keep in mind, most of the ones you're going to see are going to be irreversible. Okay? All right, and then the last thing we want to talk about is how do we recognize a reaction. So if you think way back to Unit 1, we talked about chemical change and physical change and recognizing chemical change. Well, some of those evidences we see are how we can some of those evidences we saw for chemical changes are what we use to recognize a reaction. Okay, this process of really going under a chemical change or undergoing a chemical change. Okay, so for example, burning a wick on a candle, right? We can see some light. There's some gas produced. Okay, there's an odor. Those types of things are what we can use to recognize a chemical reaction. Okay, so here are some evidences we can see. Okay, a change in temperature. Okay, some heat is released or absorbed during the reaction. Okay, an explosion is a good example of that, right? The production of a gas bubbles, smoke, other things like that. Okay, can be evidence of reaction. The production of a solid. Okay, if a solid kind of settles to the bottom of the liquid solution, okay, then that is a evidence. Okay, this is called a precipitate if you really want to know. Okay, so sometimes you get this kind of solid produced at the bottom, and that's an example of a chemical reaction. Okay, so let's look at like burning wood, for example. Okay, there's heat released, there's smoke released. Okay, the ash is kind of created. It's not a precipitate, but it's kind of the same idea. It's kind of leftover material from the reaction. Okay, Alka-Seltzer and water, you can see this bubbling. Okay, sometimes you get this residue on the bottom when you put Alka-Seltzer in the water. So that's a chemical reaction as well. You can also think back to when I did that baking soda and vinegar reaction, the one everyone knows. Okay, in that reaction, there's bubbles that come out the top. That's an example of a gas being produced. Okay, and there's definitely an odor that's produced. It smells pretty bad. And then if you actually ever feel that reaction, it's actually very, very cold. Okay. If you ever feel the bottom of that glass after you do a baking soda and vinegar, reaction. It's a very cold reaction. Okay, so it's a change in temperature, so that's an evidence of a chemical reaction. Okay, but that's all we want to cover for this part of the chapter for this podcast. Let me know if you have any questions, and thank you for watching.